In this video, I'll be doing problem 1.2.27, and we're going to do the last part, I believe, and we have this function g of x equals x over the square root of 4 minus x squared, and we're finding g of 3/4. So the biggest issue about this problem is we're dealing with fractions, and we've got to do a little bit with radicals as well. So there's a number of skills involved in doing this problem. So let's go ahead and get started. I'm going to start by making a shell, or what I call a shell, or a skeleton for the function, and we're going to plug in 3/4. So our numerator is 3/4. Now the denominator is kind of complicated, and so I'm going to do this off to the side. I'm going to simplify it off to the side. So I have 4 minus 3/4 squared. So I need to square 3/4. That's 3/4 times 3/4. When we multiply across, we get 9/16. And so we have the square root of 4 minus 9/16. Now, in order to subtract fractions, we need a common denominator. And so basically, I need to write 4 so that it has a denominator of 16. So the way we do that is, I've kind of set it up here. You can see that I need the 1 in the denominator to become a 16. And so what we do is we multiply the denominator by 16. Now in order to make it legal, we got to multiply the numerator by 16. So basically we're multiplying 4 by 16 over 16, which is 1. And so that does not change the value. But now we'll get a fraction that's equal to 4, but has a denominator of 16. That would be 64 over 16. So now we can subtract the two fractions, 64/16 minus 9/16. We're going to get 55/16. Now, we need to understand a couple of things about radicals. First of all, the square root of a fraction, we can write this as a fraction of two radicals. It's the square root of 55 over the square root of 16. And this is something we'll get into a little bit more later. It's something that hopefully you've seen before, but it's certainly something that students forget. But we can write this now as the square root of 55 over the square root of 16, which is 4. And so finally, I'm going to go ahead and plug that into the denominator. So we have 3/4 divided by, or over, square root of 55 over 4. So we can think of this as a division problem. It's actually called a complex fraction because it's fractions within fractions. But we're going to think of this as division. So we'll write this as 3/4 divided by square root of 55 over 4. Well, when we divide by a fraction, we know that's equivalent to multiplying by the reciprocal. So we change division to multiplication. We flip the second fraction. Now you can see our 4's are going to cancel. We have a factor of 4 in the numerator and denominator. And so we're left with 3 over the square root of 55. And we have one last issue here. You cannot leave an answer with a radical in the denominator. There's a whole bunch of reasons why we did that in the past. I think the main reason why we changed these, we call this rationalizing the denominator, is because it's possible with radicals to get the same answer but in different forms. And so that all of our answers look the same, we rationalize the denominator. We keep the radical out of the denominator. So we're going to do kind of a similar thing to what we did over here earlier when we multiplied by 16 over 16. I need to find something times the square root of 55 that's going to get rid of that radical. Well, it's going to be the square root of 55. It turns out that if you multiply square root of 55 times square root of 55, what that really is the square root of 55 squared. And since squaring and taking a square root are opposites, we end up with 55. So when we multiply across here, our final answer will be this 3 square root of 55 all over 55. And that's it for this one.